Today's lesson is on measures of central tendency, mean, median, mode, and range. The first measure of central tendency we're going to talk about is mean. Mean is also known as average, and it is the sum of the set of items divided by the number of items in the set. So let's look at our first example. Aaron has the following three mathematical test scores: 65, 74, and 80. We're going to find the mean for the test scores. So what we're going to do is find the total score for the three tests and divide it by the number of tests. So you'll do 65 plus 74 plus 80 and divide that by 3 because there are three test scores. So 65 plus 74 plus 80 is equal to 219, and then divide that by 3. So your answer should be 73, which means that his mean scores for the tests is 73. Let's look at another example. And while we're looking at this, we'll underline the important information that we need in the problem. 4 boys have heights of 154 centimeters, 157 centimeters, 160 centimeters, and 165 centimeters. What is the mean height of the 4 boys? So we know that we're going to do the sum of the height of the boys divided by the number of boys. So we will add together 154 plus 157 plus 160 plus 165 and divide that by 4 because there were 4 boys. So when we add those together, we get 636, divide that by 4, and the answer is 159. So that means that the mean height of the 4 boys was 159 centimeters. Here are some practice problems I'd like you to try by yourself. Pause the video, and after you've found the means, we'll go over it together. Now that you've had a chance to solve the problems, let's check our answer. So the first problem is the number of goals scored by 7 forwards in one soccer game were 8, 6, 4, 8, 3, 1, and 5. Find the mean number of goals scored by the 7 forwards. So we'll add 8 plus 6 plus 4 plus 8 plus 3 plus 1 plus 5 and divide it by 7 because we know that there were 7 forwards in the soccer season. So after we add up those totals, you should have gotten 35 divided by 7, which is equal to 5. So the mean number of goals scored was 5. Let's try number 2. The masses of 6 chairs are 34.5 kilograms, 42.6 kilograms, 39.8 kilograms, 40.1 kilograms, 53.4 kilograms, and 33.8 kilograms. Find the mean mass. So we'll add 34.5 plus 42.6 plus 39.8 plus 40.1 plus 53.4 and plus 33.8 and divide that by 6 because there were 6 chairs. So after you add up those totals, you should have gotten 244.2 divided by 6. And that is equal to 40.7 kilograms. So 40.7 kilograms is the mean mass of the 6 chairs. The next central tendency we are going to look at is median. Median is a measure of the center of the data, or the middle number. So let's look at an example. Barbara drew 3 number cards from a box and wanted to know the middle value, or the median, of these values: 12, 16, and 5. The most important thing to remember about median is first you have to arrange the numbers from least to greatest. So the three numbers from least to greatest are 5, 12, and 16. It's easy to see here that the middle number is 12. If it wasn't obvious to see, we could have crossed out from both ends and worked our way in. So now that we know 12 was the median, or the middle number of the set of cards. Let's look at what would happen if Barbara picked another number, 19, from the box. What is the median of this set of data? 12, 16, 5, and 19. So remember, it's extremely important that first you arrange the numbers in order from least to greatest. So this set would be 5, 12, 16, and then 19. And let's cross off the numbers starting from the least, then to the greatest. But we're now left with two numbers in the middle. So when we have two numbers left in the middle, we're going to find the mean of the two values in the middle. So we would do 12 plus 16 and then divided by 2 because there were two numbers. So 12 plus 16 is 28, divided by 2, you would get 14. So 14 is the median for this set of data. And notice that since we took the mean of the two middle values, the 14 isn't necessarily in the number set. Let's recap what we learned about median. When a data set has an odd number of values, you can identify the middle value, or the median, by inspection. The number of values less than the median equals the number of values greater than the median. So here, since we had 3, we can see that 12 is in the middle, and there's 1 on the lower side and 1 on the greater side. Also, when a data set has an even number of values, you can identify the two middle values, and then the median is the mean of these two middle values. So with our last example, we crossed off the least and the greatest, and then we found the median number by doing the mean of 12 plus 16 and dividing that by 2, which was 28 divided by 2, which was equal to 14. And like I said, it's not necessarily a number in the data set. Let's try one more example before you practice it on your own. So the data shows the ages of a group of people. What is the median age? 23 years, 36 years, 28 years, 43 years, 34 years, and 29 years. So remember, our star is there to remind us that we first have to order the numbers from least to greatest. When you're writing the numbers in order from least to greatest, you can cross out the numbers on top so that you know if you used it or not. So first we would have 23, and then cross it off, 28, and then cross it off, 29, 34, 36, and 43. And now remember, the median is the middle number of the data. So we could start with our lowest number and cross it off, then go to our highest number, then back to our lowest, back to the next highest, and then we have two numbers left in the middle. So we're going to find the median number by finding the mean of the middle two values. So 29 plus 34 divided by 2. That would get us 63 divided by 2, which is equal to 31.5. So 31.5 is the median age, and notice, it's not in our data set, but that's still okay, because we found the mean of the middle two numbers. Now try these problems by yourself. Press pause, and after you found the median, we'll go over it together. Now that you've had some time to do the problem yourself, let's go over it and see what we get. Number 1 says, the data set shows the weights of a group of students. What is the median of the weights? 109 pounds, 86 pounds, 117 pounds, 97 pounds, and 98 pounds. Remember, the most important thing about these problems is that we order them from least to greatest. So least to greatest would read 86 pounds, and cross it off so you know that you used it. 97 pounds, 98 pounds, 109 pounds, and 117 pounds. And now you can cross off starting from the lowest and then going to the highest and working your way in. And we would see that we'd have one middle value, which is 98. So 98 is the median of the weights. The next problem says, the data set shows the lengths of the tables that one company produces. What is the median of the lengths? 85 centimeters, 92 centimeters, 108 centimeters, 264 centimeters, 200 centimeters, and 135 centimeters. So the first thing we're going to do is number them from least to greatest. So we'd have 85, 92, 108, 135, 200, and 264. Then you can cross off starting from the lowest and work your way in. Then we would see that we have two middle values. So when we have two middle values, we have to take the mean of those two numbers. So the mean would be 108 plus 135 divided by 2, because we have two numbers. So 108 plus 135 is 243, and divide that by 2, which would be equal to 121.5. So the median of the heights of the tables is 121.5 centimeters. The next central tendency we're going to talk about is mode. Mode is the number that occurs most often in the data set. So our example is, Ryan tossed a number cube numbered 1 to 6, and he recorded the following data for the numbers he rolled: 5, 3, 1, 6, 6, 2, 4, 5, 2, 3, 5. So in order to find the mode, we can list all the different numbers that he rolled and see which one occurs most. So he rolled a 5, a 3, a 1, a 6, another 6, a 2, a 4, and then another 5, another 2, another 3, and then lastly another 5. So from listing the numbers and putting the tick marks next to them, we can see that the most numbers he rolled was 5. So for Ryan, the mode was 5. Let's try another example. Justin recorded the times for the 10 runners on a track team when they ran the 100-meter dash. The data set shows the times that he recorded. What is the mode of the data? 10.1, 9.8, 10.3, 10.2, 10.1, 9.9, 10.0, 9.8, 9.9, and 10.1. So again, we can list out all of the data and see which one occurs most. So first we did 10.1. And since there are a lot more numbers here, we can cross it off so we know that we used it. 9.8, 10.3, 10.2, another 10.1, 9.9, another 9.9, 10.0, another 9.8, another 9.9, and another 10.1. So as we can see from the data and the tick marks that we did, there are two numbers that have two check marks, 10.1 and 9.9. So since we had two numbers with the most repeating numbers in the set, we can see that there are two modes. Here's another problem we can try. The data set shows the masses of the school bags of some students. What is the mode of the data? So in kilograms, our data set reads 5.5, 6.6, 4.8, 4.3, 5.4, 6.2, and 5.9. So let's list out our data and see if we can find a number that appears the most. So we have 5.5, 6.6, 4.8, 4.3, 5.4, 6.2, and 5.9. As we can see, all of the numbers occurred exactly once, so no number occurred more than any other number. So here, our data has no mode. So we know mode is the number that occurs most often in the set, but from our last two examples, we can see that there are some other exceptions. So if we have two or more numbers that appear the same amount of times and appear the most, there may be more than one mode in the data set. So for example, if we had the data set reading 1, 2, 2, 3, 3, 4, and 5, we can see that 2 appears twice and 3 appears twice. So our modes are 2 and 3 because they both appear the most amount of times. Also, if all of the numbers in a data set appear the same number of times, there can be no mode. So for example, if we have 1, 2, 3, 4, and 5, it's clear to see that there is no mode because no number appears more than any other. Here's some more practice. Pause the video and try these on your own, and then after we'll go over it together. So our first problem reads, the scores of a basketball team in a series of games are 76, 85, 65, 58, 68, 72, 91, and 68. Find the mode score. So for this problem, it will be helpful to list out all of the scores. So there was a 76, an 85, and then you can cross those off too. 65, 58, 68, 72, 91, and then a 68. But we've already listed 68, so we're going to check it off. And then from here, it's clear to see that 68 is the mode because it appears twice, while all of the other numbers appear only once. So the next practice we can do is, Elise likes to bowl. These are her scores for the 10 frames that she bowled in one game. What is the mode score? So we have 12, 8, 10, another 8, 11, another 8, 9, another 12, another 11, and another 12. So now we can see that here in this data set there are two modes, 12 and 8, because they appear the most. The last measure of central tendency we're going to talk about is range. Range is the difference between the greatest and the least number in a set of data. So for example, the data set shows the amount of money 10 children spent in a week. What is the range of the money spent? $16, $13, $11, $19, $17, $28, and $15. So here, the largest number was 28, and then the smallest number was 11. So now we need to find the difference between the greatest and the least. So we will do 28 minus 11, which is equal to 17. So the range in the amount of money that the children spent in 1 week was $17. Let's try this example. What is the range of the data? 32.6, 72.6, 23.6, 45.4, 88.7, and 69.9. So first let's identify the greatest and the least number. So the least number is 23.6 and the greatest number is 88.7. So 88.7 minus 23.6 is equal to 65.1. So the range of this set of data is between 65.1. So again, practice these on your own by pausing the video, and then after you're done, press play and we can go over it together. So the first problem says, the cost of 4 cell phones are $345, $400, $110, and $640. So let's find the greatest and the least amount of money that the cell phone plans charged. So the greatest is $640 and the least is $110. So we need to find the difference between those two numbers. 640 minus 110 is equal to $530. So the range in the 4 cell phone plans are $530. The next problem says, the number of points scored by 7 students on a Spanish test are 68, 46, 74, 58, 63, 91, and 85. What is the range of the test scores? So here, the biggest number was 91, and the smallest number was 46. So the difference between 91 and 46 is equal to 45. So the range of the Spanish test spans between 45 points. Let's recap what we learned today. Mean is the sum of a set of items divided by the number of items in the set. Median is the middle number in the data set. And the most important thing we need to remember with that is to first arrange the numbers from least to greatest. The mode is the number that occurs most often in the data set. And remember, we can have 1 mode, 2 modes, 3 modes, and so on, or no modes. And lastly, range is the difference between the greatest and the least number in the data set. I hope this video helped you and that you're an expert now on mean, median, mode, and range.